So this video is for the solutions for our second trig identity sheet. I must admit that this identity sheet is a little more challenging than the previous one. It starts off pretty simple, but the ones at the end get a little more complicated. But it's a really good practice sheet for the test. Alright, let's go try to prove some identities. So like I said, the first few are really grade 11 trig identities. So like 1A is really grade 11, 1B is grade 11, 1C is grade 11. So I'm not going to spend that much time on A, B, and C. In fact, it really goes, it's still grade 11. You know, I'll tell you when it's a grade 12 trig identity. So 1D, I tried to save some time. I think this is one of the more efficient techniques of how to prove 1D. But you know what? Like I said in the other trig identity homework sheet, it really doesn't matter how many steps you take. As long as your proof makes sense, I'm going to give you full marks. So this is my approach. I expressed it as sine x times cotan x plus 1 all squared. And then sine x times cotan x is cos x, and sine x times 1 of course is sine x. I simplified this by, I factored cosine x because that's going to give me cos x times all of tan x plus 1, and then I square each factor. Okay, what about E here? E, I'm looking at it, it's really still a grade 11 identity. Nothing about it is screaming grade 12. I didn't use a compounding. I just did the factoring and simplifying that I learned from grade 9 and 10. Okay. How about F here? Yep, not much to say about F. I use some grade 11 Pythagorean identities. I factor out -1, and then I basically use Pythagorean identity 2 times, and then I was able to show that the left side is negative tan squared x. 1G is a very common grade 11 test question, factor using difference of squares, and then you have the Pythagorean identity. I really wish I wrote cos 2x, because why not? I taught you the double angle formula for cosine. Might as well use it. Anyways, it is what it is. So that's G. H here finally. Okay, now we're using some grade 12 identities. So this is a subtraction formula for cosine. Break it apart into the sum of two terms because that's what the right side is. So you go from a single fraction to two fractions essentially. You want to go from one fraction to two fractions. And then it simplifies perfectly. Okay. For I use addition formula and subtraction formula for sine. Now here, I took a close look at what I wanted on the right side, and you may not have came up with this idea, but multiply the numerator and denominator by secant x, secant y, and it works out perfectly. Okay, let's take a look at J here. J, so secant x over cosecant x, because secant x is a reciprocal cosine, and cosecant x is reciprocal sine, so I know it looks strange, but secant x over cosecant x is quite simply sine x over cos x. And that's of course tan x, so I have tan x plus tan x, which is 2 tan x. K, let's see, what do we do for K here? I simplified the numerator by using the reciprocal trig identities, simplify the denominator using the quotient identity, and then just some basic algebra, and you're left with 1 over sine x. As long as you maintain good algebra, you should get the right answer. Okay, that was A through K. Let's do L here. So for L, I work with the left side. I just simplified. So this has nothing to do with grade 12, but it's good practice though. It's all about practicing your algebraic skills. So these reps are gonna help you out. M. Oh, just expand. I know it looks funny, but you're just applying the distributive property here. If you do it correctly, you'll get negative tan y plus tan x, which is same as tan x minus tan y. Okay, n was one of the harder ones. So n, I work with the left side, but to be honest with you, this one, you could work with either side and the work is about the same. So I actually want to multiply by the conjugate of the numerator as well as the conjugate of the denominator. Okay, so this one's a little tricky. So sometimes when you see an identity like this, where basically the numerator and denominators are very, very similar except for a switch in the sign. So like, look at this. You have cos x minus sine y, and on the other side you have cos x plus sine y. Then you have on the left side you have cos y and sine x, cos y and sine x. It's just the signs are different. So that's a big hint to multiplying by the conjugate. Okay, so the first step is critical. So if I'm working with the left side, I really want this. I don't want to touch cos y plus sine x. I want to leave that alone. And as for the denominator, I want to leave cos x plus sine y alone. Now, why would I want to leave this alone and this alone? Because if I leave these alone, guess what? I have the right side of my identity. So I really don't want to touch this. Just let that be, okay? So I'm going to manipulate these ones, the remaining coses and sines, because if I do it correctly, the product of this and this over this and this will be equal to 1. Okay, so I did a whole bunch of simplifying. So when you multiply cos x minus sine y and cos x plus sine y, you get cos squared x minus sine y. And when you multiply cos y minus sine x with cos y plus sine x, you get cos squared y minus sine squared x. Okay, so like I said, don't touch this because I just want to simplify this to be 1. Now, it seems a little hopeless, but wait a minute. Just use the Pythagorean identity, and then you're done. So I change cos squared x to 1 minus sine squared x, and I change sine squared y to 1 minus cos squared y. And lo and behold, it simplifies and it works out beautifully. Okay, so that was one of the harder ones. Then we go back to the easier ones. So addition formula for cos and subtraction formula of cos, find the product. I don't want to see a single sign, okay? Because look at the right side, it's cos squared a. Oh, I do want to see a sign, sorry. I see cos squared a minus sine squared b. So what I want to do is take away this cos squared b using the Pythagorean identity and take away the sine squared a using the Pythagorean identity. So because I don't see cos squared b on the right side and I don't see sine squared a on the right side. Yeah, it's basically you have to keep an eye on both sides to see what you want to get rid of, and how you go about doing that depends on which trig identity you're going to use. So remember, the number one rule to proving trig identities is memorizing all the trig identities. You need to know your tools very well. Otherwise, you can't generate the efficient way of solving the identity, or worse yet, you might not be able to prove the identity at all. Okay, so Q here, you have the subtraction form for cosine in the numerator, and then break it apart to two fractions, and that's it. For R, addition formula for cosine, subtraction formula for cosine, simplify. That's one of the easier ones, in fact. Okay, we have S to X. So for S, we have subtraction formula for cosine and addition formula for cosine. That one's pretty straightforward. It simplifies very nicely. For T, we have addition formula for sine and subtraction formula for sine. Find the product of those two. I don't want to see cos squared q, and I don't want to see cos squared p. Get rid of both of them by using the Pythagorean identity. U is very similar to T. So addition formula for sine, subtraction formula for sine, find the product. The product, by the way, is a difference of squares. It's a plus b, a minus b. They're conjugates. Anyways, I don't want to see sine squared p and I don't want to see sine squared q. Get rid of them using the Pythagorean identity. Ooh, V, triple angle. Nice. So the first step is to break apart 3x into 2x plus x. And then use the addition formula for sine. And then use, I see sine 2x now, and I see cos 2x. Use the double angle formula for sine and cosine. And then it works out beautifully once you simplify. W, double angle formula for tan, and then once you simplify, the half is gone, and then multiply the numerator and denominator by cos squared theta, and you're essentially there. Yeah, it has a negative in the numerator, negative sine theta cos theta, but I got rid of the negative by multiplying the denominator by -1. Last one, x. Okay, so x is really nice. So I factored out sine x cos x. That was my common factor. And then I saw cos squared x minus sine squared x. And once I see that, I think of double angle formula for cosine. Multiply numerator and denominator by 2. Because I saw that, oh, sine x cos x, I can change that to sine 2x. I just need a 2. So multiply numerator and denominator by 2. This is sine 2x. Cos 2x, well, I need another 2 to use the double angle formula again. So that's what I did, and that becomes sine 4x. So I'm left with sine 4x over 4, which is exactly the same as a quarter sine 4x, and that's what I really wanted. Perfect. So this identity sheet is a little more challenging than the previous sheet, and this is more in line with what the test is going to be.